Have you ever looked up at a skyscraper and wondered, how on earth does that thing stay up? Well, you're not alone. Today, we're diving into the mind-blowing science behind impossibly tall buildings. Buckle up, because we're about to reach new heights. Let's start with the basics. Foundation. Imagine trying to balance a pencil on its tip. Now imagine that pencil is 1,000 feet tall. That's the challenge engineers face with skyscrapers. The solution? Go deep, really deep. Some skyscrapers have foundations that extend hundreds of feet into the ground. These foundations are often wider than the building itself. They're like massive underground pyramids, spreading the weight across a larger area. But it's not just about going deep. It's also about what's down there. Engineers use a variety of foundation types depending on the soil conditions. In some cases, they might use piles-long, slender columns that transfer the load to deeper, stronger layers of earth. In others, they might use a mat foundation, a thick concrete slab that spreads the load across a wide area. Now let's talk about the building itself. The key here is the core. Think of it as the spine of the building. It's a central structure that runs from the foundation to the top of the building. This core houses elevators, stairwells, and other utilities, but more importantly, it provides crucial structural support. Around this core, engineers use a variety of structural systems. One common approach is the tube system. Imagine a hollow tube made of steel or concrete. That's essentially what many tall buildings are. This design allows the building to resist lateral forces like wind, which become a major concern at great heights. Speaking of wind, it's one of the biggest challenges in skyscraper design. As buildings get taller, they have to deal with stronger winds. To combat this, engineers use a variety of techniques. One is to create a tapered design where the building gets narrower as it gets taller. This reduces wind resistance. Another technique is to include sky lobbies or open floors near the top of the building. These allow wind to pass through, reducing the overall force on the structure. Some buildings even use tuned mass dampers. These are enormous pendulums, often weighing hundreds of tons, that counteract the building's sway in high winds. It's like a giant shock absorber for the entire building. Now let's talk about materials. Steel and concrete are the stars of the show here. Steel is incredibly strong for its weight, allowing for taller, lighter structures. Concrete, on the other hand, provides mass and stability. Modern skyscrapers often use a combination of both, known as composite construction, but it's not just about strength. Flexibility is crucial too. Skyscrapers need to be able to move and flex in response to wind and even earthquakes. If they were too rigid, they'd snap under these forces. This brings us to an interesting point. Skyscrapers are designed to move. In fact, the top of a tall skyscraper might sway several feet in strong winds. Don't worry though, this movement is entirely normal and safe. Let's talk about elevators for a moment. They might not seem like a structural concern, but they're actually a major limiting factor in building height. Traditional cable elevators can only go so high before the weight of the cable itself becomes a problem. To solve this, engineers have developed new systems, like magnetic levitation elevators that can move both vertically and horizontally. Now you might be wondering, how tall can we actually build? The current tallest building in the world, the Burj Khalifa in Dubai, stands at 2,717 feet, but theoretically, we could go much higher. Some engineers believe a mile-high skyscraper is possible with current technology. The real limitations aren't technological, they're economic and practical. At a certain point, the amount of space taken up by structural elements and elevators makes adding more floors impractical. Plus, there are other concerns like emergency evacuation and the simple fact that not everyone wants to live or work that high up. But engineers and architects are constantly pushing the boundaries. New materials like carbon fiber composites could allow for even taller, lighter structures. Advanced computer modeling helps designers optimize building shapes for both structural integrity and energy efficiency. And it's not just about going up. Some designers are exploring concepts like earth scrapers, inverted skyscrapers that go down instead of up. Others are looking at horizontal skyscrapers that could span entire city blocks. The future of tall buildings isn't just about height, it's about sustainability too. Many modern skyscrapers incorporate green features like solar panels, wind turbines, and advanced waste management systems. Some even have entire forests built into their designs. So, the next time you look up at a skyscraper, remember, you're not just seeing a building. You're seeing the culmination of centuries of engineering, physics, and human ingenuity. It's a testament to our ability to overcome challenges and reach new heights, literally. If you found this video interesting, please like and subscribe for more mind-blowing science. And let us know in the comments, what impossible feat of engineering would you like us to explore next? Until next time, keep looking up. There's always something amazing to see.